binary search. Again, let's have a quick recap. So these are the variables. This is the array. And here is the number of elements, the left index, right, middle, our found 0 when not found, 1 when found. Then here is the item that we'll be searching. In our source code, we have here our loop. So we keep on searching while not found and left is less or equal to r. That means, so yung left is less or equal to r. That's true if, let's say, we haven't, more or less, there's still a possibility that the item is inside the array. So, and if it's not yet found, we keep on searching. So every time we search, we first get the middle index. So once you get the middle index, we compare the item with the element at the middle index. So if they are equal, then that means found. So we change the variable found to 1. If the item is higher than the middle element, then that means that the item may be on the upper right side. So what we're going to do is to change the leftmost index. So the left portion of the array will be ignored. Else, that means it is lesser, so it will be the reverse. The right portion of the array will be ignored, and we now change the right index. So equal to m minus 1. That means the element before the middle element. So we keep on doing this until we were able to search the value, or this becomes false also. That means it is not found. So after the loop, we just test if found is equal to 1. Then that means we pass through this line, and that means the search was successful. So we can now print the item itself and the position. So item is item and the position m. Or if found is not equal to 1, then that means the loop exited because this one becomes false. As you notice, we're using and, so both should be true. So when this becomes false, that means it did not pass through this part. Then we just print a message saying that the item was not found inside the array. So that's our code. Now let's try to make some revisions. I want to use random numbers. So let's say I'm going to use 20 here, and will not be initializing the array. Okay, so the item will be entering the item. So maybe item equals 0. But how do we generate random numbers? So if you are not familiar to how to generate random numbers, you can make use of course, the internet. So I searched, and then it is how we generate random numbers. So we're going to generate 20 random numbers. So include time, then include, so that's time each. So let's include that in our code. That's wrong. Include time dot each. And then here, uh, let's say we have here our random number, or maybe equals 0. And the integer I equals 0. I will be our loop counter, and this will be the random number. So first, what we're going to do is what? So we're going to place this code once, so that more or less the numbers that will be produced will be really random. And then we'll have here a loop. For I equals 0, I is lesser than 20 or lesser than n. So we replace this one with 20. Then we have here I plus plus. So we're going to loop 20 times. Then we generate the random number. Okay, so that's how we generate random number. Let's check. So RAND, open and close. So let's try to limit the value only up to 100. So we place here modulo 100. So that means we divide the number by 100 and then we get the remainder. So the remainder will be our random number. And then we assign the random number to our array. So I is equal to RND. Okay. So what we did here is we generated random numbers and then we assign the random number to the array. But we have a problem here because we cannot use binary search if the array is not sorted. So what we're going to do after this is to sort the array. So how do we sort the array? Let's first declare variables that will be used for sorting. So I have here integer swap equals 1, integer t equals 0. This is our temporary variable. Let's first see. So while swap equals 1, swap equals 0. So that's we loop while there's still swapping. And first we swap for I equals 0, I is lesser than n minus 1 because we're going to compare from 0 up to the second to the last element, then I plus plus. Hopefully I'm not mistaken with my code. So what we're going to do, we compare if LAI, so the first number should be what? Lesser. So if it is greater than the next number, then we swap. So how do we swap? T is equal to LAI, LAI is equal to LAI plus 1, then LAI plus 1 is equal to LAI. Then so we swap, therefore we place swap is equal to 1. And I think that's already our sort algorithm. So we keep on uh, looping while swap is equal to 1. So then we assign 0 to swap. Then we compare the adjacent values. So if we pass to this part, that means swapping was done. So if swapping was done, we keep on repeating the element until the time that during that pass, these codes were not executed. So the volume swap was not changed. Hopefully, it's still correct. The next year, enter the value of the item. So how do we enter the value of the item? Scan F. Please enter item. Then replace it. Oh no, that's wrong. It should be print F. Then we have scan F So that's our input, %d, and then the address, ampersand, item. Then we have now our search algorithm. We're not going to change anything in our search algorithm. So what we have done is just to assign random numbers to the array. So that is what we have done here. Then again, we should sort the numbers because we can only use binary sort if the elements of the array is sorted. So let's double check. Hopefully everything is okay. So let's try to run the program, execute, compile and run. So enter an item, but I don't know any value inside. 40. So foil item 40 was not found. Okay. So maybe our program is correct. So let's cheat a little. So after sorting, let's display the numbers so that we will be so display the numbers. But of course, we should not do that. But let's try a little. So for I equals 0, I is lesser than n, I plus plus. So print f percent 5d LA indexed by I. So after the loop, printf backslash n backslash n. So we have two spaces. Okay, so what we did here is we just loop from 0 to 19 or whatever the value of n is. So our n is 20, so that's up to 19. 0 to 19. So we just print the value of LAI, indexed by I. 5D, we allocated 5 spaces. So since our numbers will be up to 100 or up to 99, okay, this will have more or less spacing between the numbers. So actually, we're just going to cheat so that we will be checking if our search is successful. So let's again run the program. That's our random number. So let's try 7. So hopefully you can search 7. Yeah, so 7 is found at position 18. Okay. So that means we were able to search for the right. Our random did not generate very random numbers, but that means our code is already okay. Okay. So just to recap, what we have done here is we just added what random numbering. Now this one will actually make your random number really random. And then here we assign a random number. We just get the modulo so that more or less we'll have smaller numbers. And the values are inserted or inserted inside the array. The next we sorted. After we sorted, this one is optional. Just display the values. After we display the values, we now enter the item to be searched. So once we enter the value, then we have now our search algorithm. Okay, so more or less these are the things that we can do with the search algorithm. We can make some changes. Okay, so we can even try to increase this value. Let's say we have 100 items. So we just place the 1 to 100, what is 1 to 100, and then that means we'll be generating 100 numbers now. Okay, so that's all for today.